Hello, today we are going to try to fix this absolutely beautiful 24-volt kettle that was intended to be used inside of a truck vehicle because we've got a 24 volts DC there, and according to the manufacturer we should get around 250 watt, so it should be much better and much faster than using 12 volt system, basically like more than half, but it is not working. It is some sort of customer return and someone returned it to the seller as not working, and this is why I purchased it as in a good price. Here I've got a high current power supply that we are going to be using for testing. As you can see, the front connector are using only 5 amp, so I'm using the back one, and we are going to enable our device. I'm on 27 volt. I'm going to set up 10 amp of current, and we are going to be connecting into our cigarette lighter plug. Just like this, the positive on top. And we are going to try to power it on. And I can see the indicator, and I've got absolutely no current. So we've got something not working properly. I can hear a click inside. We know for a fact the fuse in the cigarette lighter plug is okay because it's powering on. So we need to open it and take a look inside. As you can see, it was imported by French company, but I would assume this means that it was made in China. To get access inside, we need to unlock those elements. And I believe this is the way to do it. And it go absolutely beautiful. Let's take a look what we've got inside. So we've got pretty not nice, because I can see that we've got a melted plastic. Absolutely not good. Here I can also see melted plastic. So I'm not sure if we are going to get a good fix. I make a visual look what we've got inside. Over there we've got a thermal switch that is resetable. On back of those red wires we've got something that I deeply believe is a one-time cut-off fuse. And here we've got connector to the boiling, the heating coil that looks absolutely beautiful, and it's going to be fully submerged in water. This is the best design. So we are going to check the resetting fuse, and we are going to check the one-time fuse. So let's see what happened. We've got my ohm meter in the continuity mode. And first I'm going to check the resetable bimetallic switch, and it's fully connected, it's passing current. Let's measure the fuse, the thermal fuse, and it's not passing any current. So we know for a fact that we have to replace our fuse. And most likely, if you ever got into a situation like this, that means that this device saves you from burning things, and it's mean the resetable device, the bimetallic thermal switch, fail and it go totally close and didn't break and disconnect the load, and it was thermally going run away, and it protected you. So if you go into a situation like this, you always replace those two elements. I do not have any water, so I will be very quickly. We are just going to see if the current spike. Yes, we've got a 10 amp, absolutely beautiful. So the heating element is okay, we need to replace those two devices. And most likely it's going to be working just fine, so let's do it. And here is our device, the bimetallic cutout switch that we are going to be replacing. Is that a thermal fuse? It's hard to get a good reach. And yes, we've got our fuse. It's got 167 Celsius degree, and it is 100% correct. You want to go much higher than your regular temp, because you are relying on the self-resetable, and it is also in thermal runaway. If you fail, then the temp is going to be rising much higher and it will be acting, so I have to find a replacement. I do not have exactly 167 Celsius degree, so I will go with 165. I believe those 2 Celsius degree will not make any difference, and I go with the lower direction, so it should just act faster, just act sooner. The worst case, it will trigger as a false positive. So let me attach it. You should never solder them, because if you put your soldering iron that is going to be hot, then it's going to be transferring into fuse and you are going to trip it. That's why they are crimp. I do not have exactly the same crimp, so I grab that slug, I cut this element and I use it for crimping. Is it beautiful? Is it great? Absolutely not, and do not follow that way, but looks like it's going to be working. So yeah, let's try to do it that way. Do you remember those disclaimers, do not try at home? And this is one of those things. Absolutely do not do it that. I'm using a wrong crimper on the wrong element on, yeah, totally not proper way. So absolutely do not try this at home, but it crimps well and I think it's going to be secure. I'm unable to rotate it. It's made out of like a brass, so it should get a good contact. And we should be good to go. Then the only thing last is to replace that element, because that was the main issue. So it is critically important for you to fully understand that that was the not reason, that was the cause. And here we've got a problem. And it was designed to be tripping at 110 Celsius degree. Do I have replacement? I've got the 110 Celsius degree. I'm not sure the current rating. Let me go like this. Go like this. We are going to be removing that. I have to swap that connector because it's using different size. So of course we are going to get a problem. And we've got it absolutely beautiful. I'm going to be nicely applying thermal paste, because we want to have a good thermal connectivity. Looks like we've got a silicone seal around, and you can see it there. So how tight we are going to be screwing it in, the better we are going to get the seal. And let's try to put it back. We are going to be plugging it in and we are going to see if the thermal switch is going to be acting properly. So let's do it right now. We've got water inside. We are going to plug it in and I will attach to the input, or we are going to be attaching here. And on the negative pole, we are also going to grab here, and we are going to be turning it on. We can pull more current, so let me allow it. We are pulling 11 amp. We are in the CV, the constant voltage, and it's working. It's getting warm. Can we see some bubbles forming? Yes, we can see very slightly around the coil. I do not feel any leak. So we are observing our device and we are going to see what's going to happen. We've got a tiny amount of steam. Bubbles are forming. And it's going to be boiling in a moment. Let me just check the connections. Like everything is hot over there. The wire is warm. I was trying to see if something is overheating. And everything is hot there. We've got a steam coming out. Very good, like, visual aspect. It's getting more aggressive. I can see that it's boiling really aggressively. It tripped. It tripped. It clearly tripped. I can see a 0 amp. The LED indicator goes off, as you can see, and it is important because it was being on back then and the water was boiled. So the first part is great, and we are going to be making our tea, as you can see, absolutely beautiful electric tea. And now we are going to check the element that we actually mounted, and I will turn it on without water. So I will remove all the water, I will press the button on, and if everything is okay, the bimetallic switch that we just installed here should protect us against overheating. As you can see, for the test we make a lot of hot water, and we are empty, and we are going to do very unsafe experiment. Just pretend that the water was boiled off, or we forget about it. I press the button, we are heating up, there is absolutely no water. It should rise to that temp, and it should kill itself. Let's take a look at the amp. It trigger, it safely go off. As you can see, absolutely beautiful. We clicked, we disable, we are safe. We didn't burn our motor home. And after it cooled down, it should re-enable itself. Keep in mind, we are now waiting for cooldown. The element that we replace should cool down and should trigger back. We don't want our single use to go off each time when this situation happens. If it go back, then we made absolutely beautiful fix. So let's give it a second. And as you were able to see, it tripped back, it shut itself off. So as you were able to see what we did make our beautiful tea. We check the 2 safety features and the device is fully operational. We boil our water, we check if it tripped on the normal switch. Did the empty water safety feature work? Yes, it worked. It didn't burn the fuse because it reactivated itself. So as you were able to see, we make absolutely beautiful fix. So thank you very much for watching. I hope you find it interesting. See you next time and bye bye.